Hello everyone, welcome to our YouTube channel Shashwat Education. I'm Ankit Soni, your teacher of physics and mathematics. Let's start with another question of exercise of chapter 7, System of Particles and Rotational Motion. Question 7.6. Find the components along the xy-z axis of angular momentum vector L of a particle whose position vector is vector r with components x, y, z, and momentum is vector p with components px, py, and pz. Show that if the particle moves only in the xy plane, the angular momentum has only a z component. First, position vector r is equals to x I cap plus y j cap plus z k cap, and angular momentum vector L is equals to Lx I cap plus Ly j cap plus Lz k cap. Similarly, momentum or linear momentum vector P is also having three components: Px I cap plus Py j cap plus Pz k cap. Okay, so we are having three vectors. We need to show that the particle moves only in xy plane. The angular momentum has only z component. First, we need to find the angular momentum vector L. We know that vector L is equals to vector R cross vector P. So we need to write x I cap plus y j cap plus z k cap cross px I cap plus py j cap plus pz k cap. We know the method. Let us solve this cross product. Taking determinant I cap, j cap, and k cap. Here x, y, z, and third row is px, py, and pz. So is equal to, therefore vector L is equals to, first we will solve for I cap into y pz minus zpy minus j cap into xpz minus zpx plus k cap into xpy minus ypx. So let's compare this equation with this equation of vector L, which is Lx I cap plus Ly j cap plus Lz k cap. So we can do one thing. Vector L is equals to I cap into ypz minus zpy. Let us take minus common out of this bracket. So plus j cap into zpx minus xpz plus k cap into xpy minus ypx. Now let us compare this equation of vector L with vector L is equal to Lx I cap plus Ly j cap plus Lz k cap. So we find that Lx is equals to ypz minus zpy. Ly is equals to zpx minus, here it is minus xpz, and Lz is equals to xpy minus ypx. So let us call this equation 1. In question, it is given that the particle moves only in xy plane. So particle moves in xy plane. Therefore, in position vector z will be equals to 0, and in linear momentum pz will also be equals to 0. So suppose we are going to put z equals to 0 and pz equals to 0 in equation 1. So Lx equals to 0, Ly equals to 0, and Lz equals to xpy minus ypx. So as asked in question, show that if the particle moves only in the xy plane, the angular momentum has only a z component. So as we can see, only Lz will be there, Lx and Ly both will be 0. If you have any queries regarding this, please feel free to mail us. You can comment in the comment section, like the video and share with your friends. Thank you.